Hello, we're going to be solving systems by elimination. What we've been looking at in class recently are systems that have been looking similar to this. If you haven't already, make sure your MJ is out so you can take some of these notes to bring with back to class. What we worked on today was something similar to this, and we thought, well, if we can combine these two into one equation, simply add them, if you will, and combine it just by this. If I have an x plus 3 more, I end up with 4x's. Here, I had negative 2y's plus 2y's, so that got rid of my y's actually, which turns out then over here, 7 negatives plus 3 positives gives me negative 4. And then we simply divide it by 4 to solve for x. And you found out that x is equal to negative 1. And then you would substitute this back in and solve for y, which I'm not going to do at this point, but you could go ahead and complete the problem if you wanted to. This is what you should know, what we worked on in class today. What I'm going to talk about tonight is something just slightly different in what if you have an equation like this. Example number 2 then is if I were to try to combine these. And remember, this is called systems of elimination, and so you want to try to eliminate one of the variables. So hopefully, let's see, if I add these, combine them together, I end up with 5x's. 3 negatives plus 6 more negatives gives me minus 9y's. And I end up with 3 negatives plus 2 is a negative 1. So at first glance, I see that this problem is slightly different than what we've been doing, in that just simple addition and combining these two equations together doesn't actually eliminate any variables. So what we're going to want to do is start fresh. There's got to be a different way in order to eliminate the variables. Now, the fun thing about elimination is that oftentimes there's multiple ways to go ahead and do this, and more complicated ones as well. If I wanted to try to add these two together and eliminate one of the variables, if I look here, I have a 3 and a 2. Not sure. I'm going to kind of just leave those the way they are. Over here, I have a 3 and a 6. Now that one kind of gives me a little bit of an idea in that I know the 3 goes into the 6. We're going to take a side note over here, and if I have an equation, let's see, 10 is equal to 10. Okay, so this is an equation because there is an equal sign right there. What if I were to add 2 to the left side? Is it still a true statement? And of course you would say, no, Miss Crest, you need to add 2 to this side as well. Okay, what if I wanted to times this whole side, we'll do this one, by 5. Is it still a true statement? No, it's not, so you'll have to multiply this side by 5 as well. What I'm getting at is it doesn't matter. You can do whatever you choose to either side of the equation as long as you do the same thing to the other side. And you won't actually be changing the equation, you still keep everything equal. So we're going to use the same concept over here in that I look at this top equation, I want to eliminate the y's here, which means, grab a different color, I'd like to somehow multiply this whole top equation by a number that when I add it to the negative 6, I end up with 0 y's. Can you think of that number? Ends up being a negative 2. So if we multiply this negative 2 times everything on this top, let's see what happens. Get rid of this guy over here. Alright, so I'm going to rewrite it right next door. Similar to distributing, that's what I like to do. Negative 2 times 3 is negative 6x. And then I have a negative 2 times a negative 3 gives me a positive 6y. And then this is going to equal a negative 2 times a negative 3 gives me a positive 6. Okay, now have we changed the bottom one at all? No, we have not, so I'm just going to go ahead and bring it over here. I end up with 2x's minus 6y is equal to 2. Okay, take a look now. If you haven't already seen this or can't see what's happening, I'll take a brief explanation here. Again, we go back to if we're solving by elimination, which means we want to try to eliminate one of the variables. If I combine the x's, it ends up, 6 negatives plus 2 more gives me a negative 4x. Now look at what happened to the y then. Over here, I had a negative 3 and a negative 6. That left me with negative 9, if you remember. Not any eliminating on that part. However, here, a positive 6 and then a negative 6. Look at what happened. We ended up eliminating our y's, and therefore over here, I have 6 plus 2 gives me 8. And then you can go ahead and solve for x. Divide by negative 4, and x ends up equaling negative 2. And then, I suppose, let's go through and solve this back here. Now, I should point out to you in that when we substitute this 2 right here, we can put it in for this x, this x, this x, or this x. It really doesn't matter. There's 4 options, and you should get the same answer for all of them. So just glancing, it's really personal preference. I guess I'll just use, oh, those technically are the same equation. Let's use this bottom one. Ew, I'm going to go like this and say 2 times 2. Whoops, negative 2 minus 6y equals 2. Again, we're going to try to solve for y. I get a negative 4 minus 6y equals 2 plus 4 plus 4. I get a negative 6y is equal to 6. Divide by negative 6. Divide by negative 6. Whoops. There we go. Y is equal to a negative 1. And then, of course, we know we want to, the intersection point is then negative 2, comma, negative 1. Let's see. What we'll talk about, too, is that I chose to eliminate the y's. We'll talk about a special case tomorrow in that, is there a way that we could actually eliminate the x's instead? And you'll see that there is a way to do that, but we don't need to worry about that tonight. I have a few more if you wanted to give these ones a shot here. Both of these, if you were to straight add these the way they are, there would be no elimination. You'd end up with 4 x's and 9 y's. So you're going to have to do some sort of multiplying to either the top or the bottom. This one I would recommend the top, in order to eliminate one of the variables. Same with this one. If I were to straight combine these right now, I'd have 3 x's. That's a negative 1 plus 3 and 2 y's. I did not eliminate any. So you're going to have to multiply either the top or the bottom by something. And in this case, you'll see you could really multiply to eliminate the x's, or you can multiply by something to eliminate the y's. It really doesn't matter. With this said, bring any questions that you have to class tomorrow. Have a good evening.